Hi everyone, this is Isaac from Santa Cruz County Outdoor Science School. At Outdoor Science School, I often go by my nature name, which is Oak. Nature names are a way for us to make kind of more of a connection with the world around us here. And I picked my nature name to name myself after the oak tree because there's lots of amazing oak trees around where I grew up and it makes me feel closer to my family. If you don't have a nature name, I want you to take a moment right now and pick one for yourself. Pick something from nature that you feel some sort of connection to. If you need a little bit of extra time to choose your nature name, you can pause this video. Think about it for a minute, and then when you get back, then hit play again, and we'll continue on our journey. So I'm really sad that you cannot be with me and the other instructors here at Outdoor Science School this week. But it is for the best. As much as we would like to be exploring around in the Redwood Forest, now is a time when we all have to be doing our part to make sure that we are keeping our community safe. And you are doing your part right now by staying at home and continuing to make sure that you're learning and engaging with the world around you. That's super duper important. So thank you again for doing your piece. What we are going to be doing today is we're going to be going on a little bit of a virtual adventure here. And I am going to be teaching you about some of the tools that scientists use to help them to explore the world around them. And so to start out with here, the only tools that you're going to need is I want you to see if you can track down a journal or a piece of paper. It doesn't have to be anything fancy. This is my scientific journal right here, but you can also just use a piece of paper if you don't have something like that. You should have something to write with, a pen or pencil, or something else that you can use to write with. And then the last thing that you need to come along with me here is that big thing in between your ears here. I'm talking about your brain. So let's turn on our scientific brains, start thinking, and get ready to go out and do some exploring. Here we go. So what we are going to be doing now is we are going to be practicing with one of the sets of tools that scientists use to help them to learn more about the world around them. And so for this activity, the last thing that I'm going to need you to find is you need some item from nature. Now, it doesn't have to be something big or dramatic. You don't have to go out and catch a deer or chop down a redwood tree and bring it back into your living room. Nothing like that. We just need something small. It could be a rock, it could be a stick, it could be a leaf, it could be a potted plant sitting on your window. It could even be something from your kitchen or from your refrigerator, a head of broccoli or anything like that. Piece of onion or cloves or garlic. There's all sorts of natural items in the world around us. If you need a moment, and if you have the ability to, it would be awesome if you could go out and find some sort of natural item outside. You should make sure that you check your parent or guardian, whoever it is that stays with you. But let's make sure that you check in with them first. And you don't have to go far, just right outside to find some natural item. And I'm sure you can find something. I, myself, am gonna go and look around here and see what I can find as well. Let's see. All right, I'm back. I found a couple of really cool things that I want to take a look at. But if you need a little bit of extra time, that is totally okay. Don't worry about that if you need some extra time. So what I'm going to ask you to do is, if you don't have your item yet, pause this video right now. Yeah, I'm talking to you. Pause this video and then come back to me once you have something. All right? Okay, awesome. So the activity that we are going to be doing is gonna help us to learn more about the items that we just found. So I'm gonna bring my camera over here and flip it around so that you can get a better look at what it is that I have in front of me here. All right, there we go. So you can see now in front of me that I have two different items that I found on the forest floor around me here in our redwood forest. So I have some sort of something that was left behind by an animal right there. And then I also have this stick that has all sorts of cool things growing off of it. So a couple of interesting items right here. And I am going to be going through this process with you here as we figure out this first scientific tool. If you were not able to find anything to use, and I encourage you to try one more time to find something that you can use in front of you, because it works better if you've got something of your own. But if you can't find anything, you can look at these items and follow along with me. All right, so what we are going to be doing now is called our 3 Eyes of Science. And our 3 Eyes of Science are a set of tools that scientists use to help them to structure their thinking and to learn more about the world around them. So the first of our 3 Eyes, our 3 Eyes of Science, is I notice. I notice. Any statement that you can begin with the words I notice is an observation. An observation. So I might pick up this, take a little closer look at it, and say, I notice that this looks like a snail shell. Okay? I also notice that it has a hole right there. It seems like it's empty. So those are a couple of I notices that I was able to come up with about this object right here in front of me. Now, if I take a look at this other item, I can come up with a couple more. So I notice the stick is brown, but whatever is growing on it is this kind of greenish color. I notice that. So those are all I notice statements. Any statement that you can begin with I notice is an observation. An observation. And observations are what scientists do to help them understand more about the world around them. They notice and make observations, and they record those observations. So this is where your journal and pencil come in. I want you to, on your very own journal, your piece of paper that you've been working on, I want you to write down 5 things that you notice about your item. 5 things that you notice about your item. And I'm gonna do the same thing right here as well while you're doing that. So this should take maybe about a minute or so. Take as long or as little time as you need, but make sure that you're actually doing this with your item. So. All right, so that was about how long it took me to write down 6 I notices that I had about my snail shell right here. And so you should have spent most of that time writing down as well. If you need extra time, that is totally fine. Don't worry about pausing this video for another minute if you need to or more to finish writing down at least 5 I notice statements about your item. What I noticed was that it looked like a snail shell. It had a black line that runs all the way around it. It's shaped like a spiral. There's nothing on the inside of it. I noticed that it's not very heavy, it's pretty lightweight. And I noticed that the top and the bottom of the shell look different. All right, so those were my I notices. I hope that you came up with some I notices as well. Because now, what we are going to be doing is we are going to move on to the next section, the next I in our 3 I's of science. All right. Our next I in our 3 I's of science is I wonder. I wonder. And any statement that that we can begin with the words I wonder is a question, okay? And so after scientists have made observations about whatever it is that they're looking at, they then move on to coming up with questions. So any statement that you can start with I wonder is a question. And so now, that's exactly what we're gonna do. So I'm gonna, again, focus in on my snail shell right here. And the first question that comes to mind for me is I wonder where the snail is. What happened to the snail that at one point in time would have been inside of this snail shell? Now for you, you might have something totally different. If it's a leaf, you could be wondering what type of tree it comes from or why it is the color that it is. I might look at this and say, I wonder why there is different colors on the bottom versus the top of my snail shell. That's another question I have. If you have a rock that you found outside, you might say, I wonder how this rock came to be where it is. There's all sorts of questions, I wonder statements that you can come up with. And so what I want you to do is I want you now to, again, grab your journal, and below where you wrote down your I notice statements, I want you to now write down some I wonder statements. I want you to come up with 3 I wonders about your item. So we're gonna write down those 3 I wonder statements right now. Grab your journal and start working on that. Three, not just 1 or 2. I want you to write down 3. So I just finished writing down my 3 I wonder statements. I wonder what happened to the snail. I wondered also, I was observing really closely that it has lots of tiny ridges all over its shell, so I was wondering why those are there. And I was wondering how old the snail was, okay? So these were some questions that I had about my snail. And once I have those questions, at that point I'm like, oh man, I'm so curious. I want to come up with some answers. And so that's what the third part of our 3 I's of science is all about. All right? So we've had I notice and I wonder. The third and final piece of our 3 I's of science is it could be. And so when we start a sentence with it could be, that is us giving a potential answer to one of our questions, one of our I wonders. It could be. Now, there's a reason that we say it could be rather than I know. And that is because scientists use language of uncertainty when they are describing the things that they know or are trying to understand more about. So it could be tells us that there is still more information that we can learn, and that science is a process of gathering more information as time goes along. So in answer to my question, I wonder what happened to the snail, I might come up with an it could be that the snail it died of old age. Because I'm looking at this and I don't see any evidence that the snail shell was broken. Okay, so I'm thinking, oh, probably there was not a predator that attacked it, because then I would see evidence of that in the snail shell. And that's the thing that scientists do when they're trying to come up with it could be's, potential answers, hypotheses for their questions, answers to their questions. They include evidence for why they think what they think. So my evidence, again, was the fact that I don't see any places where the snail's shell is broken. So what I want you to do is I want you to write out in your journal one more time an it could be, a potential answer to one of your questions, okay? And I want you to give evidence as well for why you think it could be that. So, remember to give evidence, and the best way for us to structure that is to say, it could be that blank is because, and that because is telling us that then we are adding in our evidence at that point. Okay? So, come up with a it could be for one of your 3 questions that you just wrote down. All right. Sitting cross-legged is hard for me. So I'm grabbing my journal here and I'm going to write down an it could be. All right. I just finished writing down my it could be about my snail. Again, it could be that the snail died of old age and then decomposed because I don't see any evidence that the shell was damaged by a predator. Now, some of our questions, some of our I wonders are going to be too complicated for us to answer just based on what we can observe, our observations that we're making. And so sometimes we may need to consult with other resources. Scientists spend a ton of time looking things up, using different reference materials, books, journals, websites, articles, things like that. And so, for instance, my question, why does the snail shell have tiny ridges all over it? I don't really have enough information to answer that question. And so what I might then do is I'm going to make a note of that, and then for my it could be, I have to do more research before I can come up with a good it could be. But I might start with saying just that maybe it looks like those were added on gradually, and that might be the process that this shell was grown. But I don't know that for sure, and that's our scientific language of uncertainty. So if you have any I wonders on your sheet that you were like, ooh, I don't know how to find that answer. I don't know, I can't look at this and see any evidence that that's gonna help me to answer it. Instead, I want you to think about what smaller pieces of information you would need to know to answer that question. What pieces of information would help you to get to the point of being able to write out an it could be. So those are our 3 I's of science. I notice, observations, looking at the world around us using our senses to learn more about it. I wonder, which is asking questions, being curious. And often those questions come straight out of the things that we notice in the first place. And then finally, we then try to come up with potential answers to our questions. We try to come up with it could be's. And if we don't have enough information to come up with a complete it could be, we write down the information that we would need to know to come up with a more thorough it could be. So this is a process by which scientists go about learning more about the world all the time. And many different types of scientists use this, whether they're ecologists, like we're being right now, learning more about the natural world, physicists that study the universe, or engineers that build and design and develop the buildings and roads that you use every day. All sorts of different kinds of scientists make observations, ask questions, and then try to come up with answers, which is really awesome. Hey everyone, we're back after a few technical difficulties there with our recording. As you can see, I'm no longer outside. I've moved inside. The lighting was getting kind of bad for doing this video, and then we started getting some rain as well, which doesn't work so well with the camera. I want to continue along though, talking a little bit more about what we were just discussing. We were talking about how all sorts of different kinds of scientists use the process of our 3 I's, I notice, I wonder, and it could be, to help them to understand more about the world, even if they don't use that same language. Now, all over the world, no matter what it is that they're studying, scientists use recording information as a way to communicate with one another. And so that's what you did as you wrote down your I notice, I wonder, and it could be. You have recorded that information, and you'll be able to refer back to it. You have made those observations, you've learned more about your item, and now you have a record of that. The next thing that we're going to do here together is a second form of doing that. And it takes us a little bit beyond what we were doing initially with our 3 I's to focus in on another one of our scientific tools. We have this scientific toolkit. So that is what we are going to do now. We are going to be continuing to work with our same little item. I still have my snail shell. Don't worry, it's still here. And so what we are going to do now is we are going to practice this scientific tool. And that tool is scientific sketching. Scientific sketching. So what you are going to be doing is you are going to be creating a scientific sketch, a drawing of your item. Whatever it is that your nature item was, you are going to be doing a scientific sketch of that. And I have some rules here that are going to help us to be successful. Okay. Now, some of you right now might be like, oh, yes, I get to draw. I love this. I love sketching. This is going to be awesome. Some of you may be like, ooh, I'm not sure what to think of that. I'm not much of an artist. I don't know. If you're in that second camp, don't worry. That was me when I was your age as well. I didn't think that I was very good at art or drawing or anything like that. But each and every one of you has what it takes to be successful at this. And that is because drawing is definitely a component of our scientific sketching, but we also have other pieces that we're going to make sure that we add in. That means that everybody has what it takes to include all the information that they need to teach people a lot about what it is that we're learning about here. So we're going to get started with that now.
All right. So these are our rules for scientific sketching that are going to help us to be successful. So the first thing that we are going to make sure that we do is we are going to make sure that we draw big. Okay? We're going to make sure that our drawings are large. And the reason why we do that is because it makes it much easier that way for us to include details. So when you are drawing, and again, we're going to be using our pencil and our piece of paper. So if you need to grab another piece of paper, this is important so you can draw big. We are going to make sure that our drawings are at least as big as our fist. Now that might seem like a pretty big way to make our little snail shell look, but it's going to help us to include all of those little tiny details that you can see right here. All right, so that is our first rule. We're going to draw big. Now, our second rule is that drawing is not the only way that we sketch. We also are going to be describing what we see. Okay? So that means using our words, colors, textures, behaviors, other things that we can't represent very well on paper. Just using our drawing. And so you are going to write down things like what it is that you're noticing. These are things that are in some ways pretty similar to our eye notices that we just added, but they're in particular about the visual appearance and the things that you notice about that object. All right? So describe what it is you see. Use your words for colors, textures, behaviors, and other descriptions as well. Finally, our third rule for scientific sketching is we are going to make sure that we are making measurements. Okay? So that means gauging things like size, like weight, like the number. For instance, I might describe the number of like rotations, swirls, that the snail shell seems to have here. I'd count those 1, 2, 3, 4, 5, 6, maybe even a seventh one there. I'll have to look closer when I'm not holding my camera. So we want to look at height, length, width, all sorts of things like that. And if you don't have a ruler, that is okay. You can just make comparisons to other things that you do know the size of. For instance, make a comparison against the size of your finger or your fingernail. And in that way, then you can refer back to that and you still have that information recorded. So we are now going to create a scientific sketch of whatever item it is that you have been using, that you have been describing for our I notice, I wonder, and it could be. All right? So I want you to make sure that you draw it big, draw what you see in front of you, and then describe it. Include descriptions, things like measurements, the number, the weight, length, height, all sorts of things like that. Include all of those things in your drawing. Now, this may take you some time. It may take you some time to do the work that you need to. And so what I am going to have you do is pause this video so that you can take as much time as you need. And then once you have done that, then you can hit play again and we'll come along to our final discussion here today. All right. what you're about to see is actually a time lapse of me creating my own scientific sketch. So it's only going to be a couple of seconds when you watch it, but this took me about 15 or 20 minutes of work. I really spent a lot of time making sure that I did a good job and included a lot of things in my sketch. Okay, so this was the final product that I created here, my final sketch of my little tiny little snail shell. And again, you can see how much bigger I drew it than it was itself, because that allowed me to really take the time and add in all of the little details that I wanted to include. You can see that even once I was finished with the initial drawing, I did a second drawing from a side view, because again, right, from the top, you get a pretty different view than if you look at it from the bottom or from the side, like that. And I included a ton of descriptions, whether it's colors, patterns, any sort of texturing, the fact that it's smooth, there's a little lip, things like that. So all of that is important information for us to record as scientists, and the process of becoming a better sketcher is something that can help us to be successful in all sorts of different areas of science. And it's one of those awesome areas where science and art intersect with each other, and practicing one can make you better at the other. So we have just gone over together 2 of our sets of scientific skills that we want to practice. I, notice, I wonder, and it could be our 3 eyes of science, and then scientific sketching. And again, both of these different practices, different skills, help us to be better scientists.